right, well, let's go ahead and get started. Hello and welcome. Thank you for joining our webinar today to present Indoor Air Quality with Genesis Air. My name is Mitzi Coyle, excuse me, the Marketing Director at Hutton Group, and I will be your moderator. Just a few housekeeping comments before we get started. We have your lines muted, and if you have a question or comments, please use the Q&A box to the right of the screen. For the sake of time, we will not be opening the phone line, but we'll try to address all the questions from the chat feature at the end of our webinar. If we don't get to your question, we will also be providing our contact information. No worries. We're expecting to keep this webinar to a maximum of 50 minutes. So today we will have Kevin Murphy with Hutton Group and Dan Briggs from Genesis Air. Kevin is a graduate mechanical engineer and specialized in mechanical systems, is a lead AP and has been in the HVAC business over 25 years. He currently holds the role of VP of Business Development for the Hutton Group. Dan Briggs is the president of Genesis Air. Dan has over 50 years in the HVAC industry, having spent the last 22 years with Genesis Air as its founder and president. Dan definitely knows a thing or two about IAQ. So at this time, I'd like to pass it off to Kevin Murphy. Kevin.
Thank you, Mitzi. Hello, everyone, and thank you for joining us for our webinar today. Due to the coronavirus pandemic, we have been bombarded with questions about photocatalytic oxidation technology, also known as PCO, and the application of Genesis Air PCO against the coronavirus and other airborne biologicals or bioaerosols. Our goal today is to explain the technology and show you how it can be effectively applied to clean the air. But first, I have a short, soundless video produced by the Journal of the American Medical Association. It visually demonstrates how viruses may become bioaerosols. So here we go. So what do you think you're looking at right now? Well, this is a close-up view of a sneeze filmed at 2,000 frames per second for a duration of 1/4 second. It shows a warm, moist, turbulent gas cloud containing air and mucosalivary droplets that can travel as far as 26 feet. And as we all know by now, the current social distancing recommendations for the COVID-19 pandemic specify at least 6 feet of separation. The video shows many of the larger, heavier droplets will quickly fall out of the air and land on the floor and other surfaces. However, the smaller droplets will stay airborne for varying amounts of time, some becoming very small bioaerosols or droplet nuclei, and, according to the Harvard Medical School Coronavirus Resource Center, can be suspended and circulated in the air for up to 3 hours. So that is one sneeze, cough, conversation from an infected individual can contaminate an entire space like a classroom, conference room, or other assembly area with infectious viral particles. So with that said, I'd like to turn the webinar over to Dan Briggs so we can dive into the technology and application of Genesis Air CENTERPOINT PCO. Dan, please take it from here.
Thank you, Kevin. The cloud that we're looking at are droplet nuclei. They're those particles that are less than 5 microns in size. They can last in the air for up to 3 hours. And the purpose of this seminar is really to discuss droplet nuclei as related to COVID-19. COVID-19 are 0.06 microns, so they're very small. They will be found in that cloud. They can live in a building for up to 3 hours in the air, but remember, buildings are not enclosed spaces that are not occupied. They're full of people, so we do not live in a bubble. We're constantly renewing this supply of droplet nuclei. And as we move through the presentation, we will look at the use of CENTERPOINT PCO. So if we have a chance, we'll move to the next slide and get this presentation underway. So CENTERPOINT PCO is the product that we're looking at. It's a product of Genesis Air. Variations have been on the market for the last 18 years. Let's move on. We'll see what it looks like. CENTERPOINT PCO is a panel of a pleated matrix with UV lights running through the middle that is installed across an AIRSTREAM. Some nice things to know about CenterPoint PCO. Third-party testing has proven it to work with airborne viruses, think droplet nuclei. The product itself is very scalable. It can be used both in new and retrofit applications. It has a proven single-pass efficacy by third-party tests, which we'll discuss at the end of the presentation. The rates vary depending upon the test agent, but the thing that sets CenterPoint apart is that the energy from the UV lamps is evenly distributed across the panel. The location of the reaction is within the panel. So let's move to the next slide and see how all PCOs are not created equal. By the use of the center of the panel as the source of energy, it irradiates outward onto a mesh that's coated with titanium dioxide. It's a 6-inch pleat on 1-inch centers, so the airspeed is much slower, or the surface velocity, face velocity, and having the lamps through the center of the panel ensures even energy distribution. Let's move on. This product can be used either in a retrofit or as an OEM factory installed. We also have standalone systems. The unit on the left is a 60,000 CFM air handler at San Francisco Airport. The unit on the right is a unit at Midland, Michigan in Midland Hospital. Let's move to the next slide. Let's see what it looks like in an AirStream. That's a close-up of the panel itself. Here are the main points about the panel. It destroys, it doesn't capture. As you can see, there are holes all the way through that matrix. It would not be a really good filter. Everything would get through. But that, which looks like white paint, is actually titanium dioxide or a coating. The holes are deliberate, which we'll talk about in the product features in a minute, but it makes for a very low static pressure drop. But it destroys, it doesn't capture. So this is not a legacy technology. It's not a filter. The reaction is safe. It only occurs in the panel, not out in the space. It does create a very powerful free radical, the same one we use to clean the atmosphere 7 miles up. It's energized by a UVC GI lamp, which means the product itself has a germicidal effect on surfaces within the air handling unit. It can be used in air handling units, rooftop units. It can be duct mounted. It can be standalone. We've done panels as small as 12 by 12 to 360,000 CFM air handlers in hospitals. The new systems are not brand specific, can be installed by the factory as an OEM product. It can be retrofitted into RTUs, and truly this is the biggest market. For example, train and telepack units and their retrofitting comprise over 50% of our business. But in an era where now indoor air quality is not value engineered out of a job, DX splits for things like residential systems or like commercial systems that basically use glorified residential equipment. This is a product, because of the low static pressure drop, that you can utilize where you can't put medical grade HEPA filters in. So remember, whether it's an existing or field installed or new application, PCO panels can go. Let's look at some of them being installed on the next slide. On the right hand, there are some pictures. I mentioned the static pressure drop was low. It's been measured at 0.05 at 500 feet per minute. One of the questions that often arises is, what service does it take? The panels themselves are sustainable. They last 15 years, but the service is every 12,000 hours or 15 months. But because of operating budgets, consider it an annual replacement of the lamps. Remember, you're not replacing the panel every year, so it is not the first cost again. It's simply a lamp replacement. Doesn't require much space, 6 to 13 inches. And we'll look at that on the pictures of the right. On the right top is a front load application. It has a 13-inch rack that the panels fit onto, and they can be angled towards the service person, where the bulbs can be changed, which is the maintenance. Now, if the panels do get dirty, which is one of the questions that are often asked, you can use biodegradable coil cleaner on these. It will not hurt them. Also, if it's placed downstream of a coil and you have overspray from chemical cleaners, it won't hurt these panels. Low energy. You can lower your outdoor air requirements using these panels. The 13-inch version is the upper right picture. The 6-inch version or side load is the lower right picture. Standalone units could be typified by the unit on the bottom left, which where the little silver button with the black outline on the right-hand side of the screen, there's a little plug fan in there. So you can add ductwork to it. These were developed for things like classrooms in the north and the northeast, or for conference rooms or spaces where it may not make sense financially to do the entire system, but you do want to use a product for a specific location in the building. Think standalone units. And as you can see in the upper left picture, it's fairly easy to slide the panels out on a side load application. So they're sustainable, they're self-cleaning. Let's look at some design considerations real quick. Preferred location is downstream of the coil, so we can help keep the leaving edge of the coils clean. You need to have upstream filtration with this product. You don't want to turn it into a filter. You need to be careful about the airspeed. 500 feet per minute reflects the third-party testing, so 500 feet per minute or lower. And if you're in a supply duct that's at 1,200 feet, you simply expand the ductwork out in a 3-foot section, add the panels, and then reduce it again. So side load 6 inches, front load 13 inches. And here's a really handy feature. It doesn't take much energy. Those lamps use 0.05 kW per square foot. Now that's not in the room, that's across the face of the airstream. So that's very little energy. Let's move to the next slide. How does the panel work? Now, this is not just PCO technology. This is any of the technologies that create free radicals or oxidizing technologies, and there's several on the market today. Everything from catalytic converters to bipolar ionizers to cold plasma ionizers to photocatalysts. The one thing in common, and we'll look at that on a future slide or on a slide later on in the presentation, is the creation of free radicals. What happens is an oxidation reduction reaction, which is shown on the right. What the free radical does is it breaks down the DNA and RNA of the infection-causing virus, bacteria, or mold spores on the fly. If it's odor control, and a number of Genesis PCO jobs involve airports, heliports, places where outdoor air is coming in affected by generators. We do a number of casinos with environmental tobacco smoke. By breaking down the hydrocarbon chain with an oxidation reduction reaction, you rid yourself of the odor that was a problem. It's passive. Genesis PCO products do not have the reaction occur out in the occupied space where the people are. It occurs only in the panel. And what are we using to do that? We're using a hydroxyl radical. Remember, it's a naturally occurring process. In the troposphere, the UV light from the sun hits noble metals 7 miles up, and it creates free radicals. And these free radicals reduce the amount of things like carbon monoxide and methane and other unwanted VOCs. Well, we're doing the same thing in the airstream in your air handling systems. Let's go to the next slide. The benefits. For $1 energy dollar with CenterPoint PCO, you can break down the droplet nuclei, which means we destroy, on this particular virus, it's an RNA virus, we destroy the RNA when it cannot replicate itself. If it's an odor control application, we break down the hydrocarbon chain and reduce the odor. And if it's placed where it shines on a coil, it will also keep the surfaces on your evaporator coils clean. So for $1 energy dollar with CenterPoint PCO, you can help defend yourself from virus that are in the form of a droplet nuclei being spread through the building by air handling system. You can reduce odors, and you can keep the surfaces of your air handlers clean. Now let's talk about, though, a comprehensive infection control program on the next slide. Remember, we are not a magic box that you sit in the corner and cure all the problems of the world. Those panels go across the airstream. What they're dealing with is droplet nuclei on the fly at 500 feet per minute or less. So you do the things the CDC says. You maintain safe distances. You wash your hands. You watch your surfaces. You wear gloves. You do pressurization controls in your buildings. What we're doing is helping to fill a gap. Where it says gap, that Genesis air process, that's what's happening in the panels. We're creating a free radical that destroys the RNA of something like a COVID-19 virus that is in the form of a droplet nuclei. On the right, you see a factory installed option. On the left, you see a retrofit. Let's go to the next slide. This is just defining what that video showed. The droplet nuclei size of COVID-19 is 0.06 to 0.14 microns. Even a 99.97 HEPA filter will let things smaller than 0.3 microns go through. Now, while it will capture most of it, let's not exaggerate here. There is a certain amount that goes through, and the minimum infection dosage of COVID-19, I've seen no papers that describe that as yet, but the New England Journal of Medicine reported in May of this year that COVID-19 has a half-life. In other words, it can live in the air for up to 2.7 hours. And the other scary thing is this particular disease is asymptomatic. You can have it and spread it and not know that you have it. And if you do spread it, it can be in the form of droplet nuclei. So we are simply part of a comprehensive program. ASHRAE position paper generated about infectious diseases and air handlers was started in 2009. It's been renewed through August of 2020. Capture is not assured. So what we're talking about is a technology that is an add-on technology to our legacy technologies or our filtration. Let's move on. What we're doing with these free radical creating technologies is destroying the virus on the right. But the body may still be there, but it no longer can replicate itself. So the picture on the left shows colonies of COVID-19 that has formed in lung tissue. So you go from a very small single viron or single particle to colonies in your lungs, and that's where the problem occurs. Let's go to the next slide. These free radical creating technologies have some things in common. They have an energy source, they have a location of the reaction, and they generate free radicals. So a catalytic converter, an ion creating technology, and a PCO, specifically a Genesis CENTERPOINT PCO, have some things in common and some things that are different. Let's take a look. Next slide. The differences in these products we saw on the other slide. They had a commonality in that they had an energy source. There is a location of the reaction and there's a type of free radical, but a catalytic converter, an ion creating technology, and a CENTERPOINT PCO technology don't have the same energy source. The reaction does not occur in the same place, and the type of free radical created may vary. So how do I wrap my mind around this food for thought? If you have mosquitoes in your backyard and you have children and you want them to play outside, you've got some choices. I can either use a bug zapper or I can fog my backyard. Well, if I continuously run a fogger in the backyard, my children are playing in that fog. Or do I use a bug zapper where I control where the reaction is? So the difference between CENTERPOINT PCO and ionizers is the difference between a fogger and a bug zapper. One has a controlled reaction in a known location. The other fills the space with the fog, and the reaction is totally random. Let's move on. Why do we need to care about the creation of free radicals? All of our bodies have oxidative stress. and we have a balancing act between antibodies and oxidants. When you create an overabundance of free radicals in an occupied space, you upset that balance. Free radicals can interact with molecules in your body and damage various cell components such as DNA, protein, lipids, and it gives rise to various disease states. So you want to be careful with free radicals. The key concern is, where is the reaction taking place? Let's move on. An example of an oxidizing reaction is a catalytic converter on your car. The energy source is the heat from an engine. The location of the reaction are the yellow semicircles in the picture. So you have the dirty air on the left going through the energized catalyst and coming out cleaner on the backside, exhausting out of your vehicle. So the energy is thermal. The location is within that chamber. Does it have a single pass efficacy? Yes, the EPA mandates that, and it will vary by fuel. Let's go to the next slide. Let's look at an ionizer or photohydroionizer. They do have an energy source, and that's the ions that they create. They create ions and they flood the space with energy, so the reaction occurs out in the space, not in a containment device. So the fellow that's sitting there with his elbow on the table, if the claim is we can kill a mold spore on that table, that energy that was required to create the free radical that killed the mold spore is also available to have a reaction in the lung tissue of that fellow and everybody else in the room. So remember, ionizers work, but are free radicals safe for people to be in that space? So an energy source that creates random reactions in an occupied space is something you might want to consider before you do. If you're trying to keep fruit and vegetables clean and last longer and take them to market, that is a great use of ionizers because it'll kill the mold in the space and on the vegetables. Simply, people don't need to be there. Now let's look at CenterPoint PCO on the next slide. CenterPoint PCO is a unique design. Photocatalysts have been on the market for over 20 years, and the designs are different. What makes CenterPoint PCO unique? What gives it the third pass efficiency that sets it, or the single pass efficiency that sets it apart? It's the location of the lamps, the way that the matrix that's coated is designed, and the type of free radical that we create. So let's go to the next slide. Be aware there are other PCO products out there that do have good first pass effectiveness, only in the area where you see the light. So if you'll notice on the left, you can see the lights. I don't know if you remember in the other slide where it showed the CenterPoint PCO, the entire panel was illuminated, but you can see the illumination where the blue light shows through the honeycomb tunnels. You can also see the dark spots that are not being illuminated. So it affects first pass efficiency. Let's go to the next slide. CenterPoint PCO is different and unique for a couple of reasons. Number one, the energy from the lamps, as you can see from the arrow pointing down, illuminates the entire panel. So we have good energy distribution. We have a pleated media, which means that media pleated on 6-inch pleated media on 1-inch centers means instead of a 24 by 24 panel, we have a significantly bigger panel when you undo that accordion, which gives us improved single pass performance. And last but not least, we've not spent a lot of time on that, but the location of the reaction only is in the panel. Why will these free radicals not migrate? Because it's the half-life of what we create, which is a hydroxyl radical. The half-life is 1/10 to the 10th seconds. It will not migrate down the ductwork out into the occupied space where people are. So here are the benefits. We have third-party testing showing proven destruction of viruses, bacteria, and mold. It can be used both new and retrofit situations. It's extremely scalable. You can measure the single pass efficacy, and our testing has been done single pass using a 52.2 device, and it will vary as far as the destruction rates by the agent being tested. Let's look at those test results on the last slide. Who's tested this product? The Department of Defense has tested it with bacteria, mold, and viruses in a single pass at 500 feet per minute. Iowa State University has tested it with a virus at slower speeds where you can actually sterilize the air, not sanitize it. Research Triangle Institute has tested it both in a single pass test using a 52.2 device and in a chamber test to get a clean air delivery rate. LMS Technologies has redone testing in the last 2 months just to confirm the efficacy of the panels. And the National Health Safety Network releases data for the Center for Medicare and Medicaid concerning the incident and the occurrences of antibiotic resistant staph. Hospitals that have CenterPoint PCOs have a 20% lower incident rate concerning MRSA than those hospitals that do not. Kevin, I appreciate you letting me talk, and I'll leave it back to you to close.
Thank you, Dan. That was great. It's especially comforting to see so many and such a variety of third-party testers to prove the efficacy of the GenesisAir PCO technology. Thanks again. Well, hopefully this webinar helped everyone better understand the technology and application of GenesisAir PCO as part of a comprehensive IAQ plan. So I see we do have some questions in the Q&A box, and I'll handle those for now, Mitzi. Dan, if you'll help me, I'll read these out. First one is, how do I know or measure my indoor air quality? Are there detectors or devices to tell me the quality and to help me monitor the indoor air? Dan, can you address that, please?
Yeah, there are a couple of things that you can do. Number one, you can get TVOC meters. You can take the air and bag it and send it to a facility that has the ability to break that air down. You also can use Anderson samplers and collect airborne biologics. Now, one of the problems with airborne biologics is it's fairly easy to test mold and to test bacteria. It's incredibly difficult to do viruses, so you want to be aware of that. One of the other challenges you'll have, CDC has no policy concerning airborne testing. CDC does a good job with surfaces. They do a good job with cleaning procedures in hospitals, but the air itself at 500 feet per minute or less or greater is really difficult to test, but it can be done. And if you need some help, we at Genesis would be happy to answer that question and give you guidance on a single pass test from a bag of air that you collect can be done. You also can take an Anderson sampler and do an air quality test and send it off to a lab near you, or a lab near you. For example, in Houston, if you had an Anderson sampler, you could send it to ELMS there in Houston, and they could do a culture. Remember, airborne biologics, you have to do a culture test. You're not interested if the body is there. You're interested in if can they reproduce. Anything else, Kevin?
Yeah, I got a few more, Dan. Here's one. PCO has a reputation for introducing ozone and formaldehyde to the treated air. What prevents the Genesis product from doing so?
The design. We have had testing done for Train. We're a source product for Train, and they have more attorneys than we have employees, rightfully so. We had to do testing using a mix designed by Lawrence Berkeley National Labs, and it was shown that our design does not produce aldehyde because it has better energy distribution and it has longer residence time. Now, ozone, all of our lamps are tested at the factory and certified to not produce ozone, but we also have received California Air Resource Board testing that shows that we do not produce ozone, and that's because of the quartz amalgam that is used to produce our bulbs. So we have had those questions appear before, and we had to answer them. And if you need further response, we'd be happy to give you the copies of those tests at Genesis Air.
Very good. And another one was, do the bulbs create ozone? You addressed that already. Here's another one. Is titanium dioxide dangerous, or I guess it means toxic?
Well, they're talking about a paper that was done with lab rats and small nanoparticles of titanium dioxide. Our particles are coated, so they're not the same size as in their original shape. They're a nanoparticle. With coating on them, they're bigger. But what we did was take the amount of titanium dioxide on a 2x2 panel and use the 10-hour exposure limit. If you took the panel, now remember, it lasts for 15 years, so the titanium may come off of it over a 10-year time period. If you took everything that was on there and you had one person breathe that all in for 10 hours, we would still be 2 orders of magnitude smaller than the 10-hour exposure limit. So it's really safe. There's not that much on the panels. You have another question, Kevin?
Yes, I do. Here we go. How long do the bulbs last?
The bulbs will last for 12,000 hours or 15 months, which is a little different than most UV lamps. But because you do an annual operating budget, even though the lamps would last 15 months, you probably will have to include in your budget replacement lamps annually.
All righty. Another one. Do the panels require periodic regeneration? If so, what is the process and frequency?
All right, they do not require regeneration because of the way that our panels are coated. A typical PCO product has a single layer of crystals that are between 50 and 100 nanometers deep. The Genesis panels are 12,500 nanometers in a photoreactive coating. So as the surface gradually responds to the light, new crystals are constantly exposed on the surface. That's where the 15-year shelf life comes from, and that's how we deal with crystal pollution. We don't have an agent that captures the ethanols that cause crystal pollution. We have a layer that breaks down, producing new crystals or exposing new crystals to the surface.
All right. Are the UV lamps low or no mercury type?
The particular lamps we use, I believe, are low mercury.
Okay. And then I'm going to try to ask these in a sensible order. Do the panels send ions into the space?
No, they don't. We use the photons from the UV light. That's why it does not migrate. We're not creating a cloud of ions. For example, a typical ionizer can create, in one test that we saw, in the center of the air chamber that they were using to do the test, they had 800,000 ions per cubic centimeter. Naturally occurring, that is from 200 to 5,000. 5,000 ions in the air occur right before a thunderstorm. But a typical device, when you look at their testing, is done at around 27,000 ions per cubic centimeter. So the overabundance of ions may or may not be a health concern. That's for a medical person, not me, but we don't produce them. We use photons off the lamp, and that's why the lamps have a limitation as to how long that they are effective. You can still see the light for years after the lamps stop working to energize the titanium, thus the 12,000 hour lamp change. What else?
We have some great questions. They're still pouring in. How does humidity affect performance?
Works better. The hydroxyl radical that we create is a breakdown of O2 into OH. So we do much better in environments where there is an abundance of H2O. One of the things that we have noticed, if it's not a recirculated job like up in the north, where there's very little humidity in the wintertime, At about 7% humidity inside the structure, the PCO panels start to lose performance. But in most cases, in buildings occupied by people and in a recirculating system, you're going to maintain a level of 30 to 50% relative humidity anyway. So that's a good question.
All righty. And then this one we're getting a lot. Has COVID-19 been tested? I suppose, have the panels been tested with COVID-19 is the question.
All right. Remember, we're creating a free radical, and it doesn't care what the agent is. It works on DNA, RNA. The answer to your question is no, we haven't used COVID-19 simply because of the universal nature of free radicals and their effect on bioaerosols. So it really doesn't matter whether it's a mold spore, whether it's a bacteria, or whether it's a virus. We have extensive testing using MS2, which is safe for commercial labs to use. We have a lot of first pass tests. MS2 is what's used by the Department of Defense at Dugway, Utah, and it's also the EPA approved substitute, and it's safe for commercial labs.
Okay, very well, thank you. Here's a similar question, but a little different. The panel life cycle is 15 years on average. Is there a meter that indicates functionality of the panel and or UV lamps?
That would be called an electron microscope if you want to see the layer of the crystals. The UV lamps is simple. Yeah, you can get a meter that will measure the intensity, and we have a minimum intensity level, which if you're interested in that, we can provide that for you if you own the product.
Okay, all righty. What is the average cost as compared to UV disinfection or NBPI?
The average cost is going to depend on the person who is selling the product. So if you have questions concerning cost, if you'll send it to Genesis Air, we'll find a manufacturer's rep in your area and let them give you cost comparisons, because the variation is pretty regional.
Very well. Does the system cycle on and off with the AHU or operate 24/7?
It just cycles on and off with the AHU. It doesn't have to build up a level to be effective. So when the air is moving, we're on. When the air is not, we're off. Why spend energy dollars when you don't need to?
Very well, very well. Some of our customers are looking at global plasma solutions. Is this just an ionization solution that you just described and may harmful effects on people and spaces?
The only thing that I can tell you, and I won't be name brand specific, it does create ions. Any ionizer creates free radicals. If a free radical is affected in a space, I would recommend you just Google free radicals in lung tissue, and you can get the answer for yourself.
All righty, very good. Here's one we see a lot nowadays. Where are the components manufactured?
All right, all of our products are manufactured in the United States. We had one lamp that was not, and we've discontinued that product. So each individual component part is generated in the United States, and all of it is assembled at our assembly plant in Lubbock, Texas. So we're a 100% United States product at this point in time.
Great, great, great. And I think this is probably the last question, Dan. I was saving it for last. Sorry, I'm scrolling up. How long have the panels been available, and can you give examples of major installations and or references?
Sure. The panels have been in the field for 18 years. The current CENTERPOINT variation with some of the last tweaking, the last patent went in actually less than a year ago, but we've had other patents before that. But they've been in the field since, really in commercial applications, probably for the last 15 years. I'll just give you some general applications. We're at Stanford University in the new Stanford Hospital. We're in the pavilion at MD Anderson. We're in 140 other hospitals. If you want a list of those locations, we'd be happy to provide it. Major airports, the new airport at Salt Lake, we're throughout. The new extension in Orlando. We're at the Delta Terminal in Kennedy. We've been used for about 8 or 9 years now at San Francisco at Terminal 2. We're throughout the airport at San Diego, and there's a list of more of that type of thing we could talk about. But we are the a sole source provider for the Chickasaw Nation, and we do all of their casinos. We're in the process of retrofitting those that don't have us. We've been at their Newcastle facility and their one at Norman, Oklahoma for about the last 2 to 5 years, depending on what phase that it went in. We're in the Bush Library, Presidential Library at SMU. We're in the National Archive in St. Louis. That's the Department of Defense Archive. So really, we have hundreds and hundreds of applications. We'd be happy to provide those, and we could provide references for those customers who are interested.
Okay. There's one other question. Will the presentation be available? Yes, it will. So if you've registered and we have your contact information, we will get you a copy of this presentation. It's we're happy to do that. Everything in that presentation is fit for public reprinting and use. Well, I think that's all we have. I don't see any more questions coming in, Mitzi. Dan, thank you so much for that very informative webinar. It was fantastic. And as you can see from here on the screen, you can, if you have any other questions, you can call Dan's compatriot Paul Roberts at genesisair.com or email him at that address, or go to genesisair.com, or you can contact your local distributor. And if you don't know who that is, you may reach out to Genesis Air and they'll let you know who your local distributor is in your region for pricing, applications, or whatnot. So Mitzi, with that, I'll turn it back over to you.
Sounds great. Thank you. All right. Thank you all for joining us today. And if someone missed this webinar that you know, please let them know. We'll be doing this again tomorrow at the same time. So catch us then. We do appreciate your time and engagement. We hope you stay safe and keep your distance from that nuclei. So everyone have a good one, and thanks for coming on. We'll see you later. Bye.